In this video, we're looking at more application of the ideas in section 3-4. And in case you haven't watched the 3-4 video yet, I recommend that you watch that first before you watch this video, which goes over more examples and application. Okay, a puppeteer cuts the pieces shown at the right to frame the stage of a puppet theater. Will the sides of the pieces on the left and the right be parallel? So will these pieces on the side be parallel? Now if you look, if I bring this piece into the other one, this angle created here will be 100 degrees. And same thing over here will also be 100 degrees. Okay, now theorem 3-8 says that if they're perpendicular to the top, then they'll be parallel to each other. But these aren't perpendicular, they're 100 degrees. Okay, so the answer is no, they won't be parallel. The next example is a proof. Okay, in a plane, C and D are perpendicular, B and D are perpendicular, and D and A are perpendicular. So prove that C and A are perpendicular. Now, before we write this proof, let's first look at why it should be true. Okay, if C and B are perpendicular, and B and D are perpendicular, now what does that tell us? Well, if you remember back to theorem 3-8, what that says, if two lines are perpendicular to the same line, then they must be parallel. So these are parallel to each other by theorem 3-8. Okay, now I'm going to extend line C for a bit. Okay, now if C and D are now parallel and D and A are perpendicular, then C and A would be perpendicular by the perpendicular transversal theorem. Okay, and that's really the essence of our proof. We'll first use theorem 3-8 and then use the perpendicular transversal theorem, and we're done. So how does the proof go? The first statement is that C is perpendicular to B, and B is perpendicular to D, and D is perpendicular to A. And the reason is it's given. Again, we always start off with the given statement, and the reason is it's given. The next statement is that C is parallel to D. And the reason is theorem 3-8. And then the next thing we'll say is that C is perpendicular to A, and the reason is the perpendicular transversal theorem. Okay, so the theorem isn't, the proof isn't very long, but it does, I think, take a lot of thinking to figure out how to use the information that you're given. Okay, in the book, problems 11 through 15 deal with the ladder. And so I want to I'm anticipating some questions about the ladder. And so I want to go through in this video and talk about, first of all, the pieces of a ladder, and also go through some example problems. Okay, in case you're not aware of it, the sides, I think you can figure out, are the sides of the ladder. But these pieces that go in between the sides are called rungs. Okay, so number 12, the rungs are parallel, and the top rung is perpendicular to one side. So I'll redraw a picture. I think pictures are helpful. So what it says is that the rungs are all parallel to each other. Okay, and the top rung is perpendicular to one side. Okay, so what we could use is, now this deals with things being parallel and something being perpendicular, reminds us of the perpendicular transversal theorem. And what that theorem would say in a ladder is that all the rungs are perpendicular to that one side. Okay, so that all of these would be perpendicular. Okay, number 14 says each side is perpendicular to the top rung. So I'll draw a picture over here. Here's my ladder. Each side's perpendicular to the top rung. Okay. Well, theorem 3-8 says that if both are perpendicular to the top rung, then the two sides are parallel. Okay. I probably should quote theorem 3-8, and I should quote the perpendicular transversal theorem. All right, a few more examples. In exercises 1 through 3, A, B, C, and D are distinct lines in the same plane. For each combination of relationships, tell how A and D are related. Okay, I'll just draw pictures with these. A and B are parallel. And B and C are parallel. And C and D are parallel. Okay, so these are parallel. These are parallel. And these are parallel. Okay, it's clear to see from the picture that A and D would be parallel. Okay, and the reason is theorem 3-7. Number 2, if A and B are parallel, and B and C are perpendicular, and C and D are parallel, let's see here, A and B are parallel, B and C are perpendicular, and C and D are parallel. Now the question is, how are A and D related? And picture that they're perpendicular. Now why? Well, first, if A and B are parallel, and B and C are perpendicular, then this angle up here, use a different color, then this angle up here must also be perpendicular. Okay, and that's by theorem, the perpendicular transversal theorem. Okay, now if I use that information along with the fact that C and D are parallel, I get that A and D are perpendicular, again by the perpendicular transversal theorem. Okay, number 3, if A and B are parallel, and B and C, let me write parallel at the end of the line. B and C are perpendicular, and C and D are perpendicular, then how are A and D related? Well, A and D look in the picture to be parallel. Okay, but why? Well, let's see here. If A and B are parallel and B and C are perpendicular, then by the perpendicular transversal theorem, A and C must be perpendicular. Okay, and if A and D are both perpendicular to C, then A and D must be parallel, and that is by theorem 3-8. So there's two theorems on this one, the perpendicular transversal theorem and theorem 3-8. Okay, that goes over some more examples and application of these ideas in 3-4.